Okay, good morning, class. To continue off, I'm again outside, so hopefully you don't hear some random sounds. So let's start with the left side, right side check for these identities. Keep in mind that for these questions, if the left side and right sides do not equal, you would state that this statement is this identity is not true. And otherwise, it is true if the two sides do equal. So taking a look at the left and right, so right away I see that there's a tan squared theta, and I want to get rid of that because I tend to want to get it into sine theta and cos theta. So my first step's going to be sine squared theta, and instead of writing this division line as a fraction line, I am going to write it so that I have it with the division sign. So sine squared theta divided by cos squared theta, because that's what tan squared theta is equal to, and that is based on the quotient identity. Okay, as a next step, well, I want to get rid of my division sign, right? And I'm going to multiply by the reciprocal. And so I have sine squared theta times cos squared theta divided by sine squared theta. These parts are gonna cancel out, and so you get cos squared theta. So in terms of my right side, that is as simple as I can get, right? And then I look at my left side, and I notice that it says 1 minus sine squared theta. And so it's a good idea to keep this formula page handy. For now, I'll just work with this copy. So I have 1 minus sine squared theta, but if I look at this Pythagorean identity, I can just move that over to the other side, and then I'll get cos squared theta. And so that's exactly what I'm gonna do, and that's how I have my cos squared theta. I have to explain that this is by Pythagorean identity. And at this point, I have explained every step. And so I need to write my therefore statement. So at least therefore left side equals right side. I can't just leave it at that. For C, I'm going to write my left side and right side. So right side looks pretty simple enough. My left side looks more complicated, noticing I have sine squared x plus 2 cos squared x minus 1. So this might be really hard to see at first, but I'm noticing this minus 1, and I know that sine squared x plus cos squared x is equal to 1. And if you have two of these, that means I could break these apart. So I have sine squared x plus cos squared x plus cos squared x minus 1. So I basically broke the 2 cos squared x out. It's not like I use a formal identity. All I basically did is if you have two things, you broke it to 1 plus 1. 2 is equal to 1 plus 1, right? The next part here, I have sine squared x plus cos squared x, and that is equal to 1 plus the rest. And this part is by Pythagorean identity. I notice that I have 1 and minus 1, and I can collect those, making sure I grab that sign in front of the number. And so I have just cos squared x. So when I compare the left side and right side, then I notice that left side equals right side. And just in case, I'll add that I just simplified. If I do, in fact, have to explain every step. Part D, we have our left side, right side. So my left side looks more complicated than the right side, but I'm noticing that cos x does not have the squared on it. So it's a case where I have these binomials. this scenario that came up. If you see binomials with sine theta or cos theta without squares, then use the conjugates. So let's interpret what that means. So right now, on my left side, I usually always habitually put brackets on that. So I am going to listen to the suggestion that to my original left side, but I've added the brackets, I'm going to multiply the top and bottom by the conjugate, and it's the conjugate with the opposite sign. That part's really important. Okay, let's see what that's going to do. We have sine squared x times 1 plus cos x divided by, well, what's going to happen by distributive property is you have 1 plus cos x and minus cos x. That's the reason why we multiply by the opposite sign, because those parts are going to now cancel out. And I have remaining minus cos squared x. Again, these two parts are going to cancel out because they're the exact same thing, but with opposite signs. So I have sine squared x times 1 plus cos x divided by 1 minus cos squared x. So see how I notice that what I'm noticing is that, well, first off, these don't cancel out, although it might look tempting to, because this one has a squared on it. But 1 minus cos squared x, that is a form of the Pythagorean identity. And I can get my sine squared x by itself by moving that over. And so reason I want to do that is because I see a sine squared x on the top, so I want them to cancel out. So I'm going to use Pythagorean identity. And you get sine squared x times 1 plus cos x divided by sine 2x. These parts cancel out, and you're left with 1 plus cos x. You have the exact same thing on the right side. So I've already kind of gone through this prior to going through this lesson with you. But when I'm actually solving a proof for the first time, I often have to go check back and make sure that my more complicated side is looking really, really close to my right side, okay? And you're making those moves based on it. Left side equals right side. This proof is true.
Okay, so for question E, I'm noticing that right side versus the left side. Well, the left side looks very much more complicated. So for now, I'm going to work on the left side. So as a reminder that secant theta, you can write it as 1 divided by cos theta. And cosecant theta is 1 divided by sine theta. Cotangent theta is 1 over tan theta. So I've completed these based on the reciprocal identity. So remember, when you're multiplying fractions, you're going to multiply across like that. And so you have 1 divided by cos theta sine theta minus, well, 1 over tan theta is cos theta divided by sine theta. And here I used quotient identity. Keep in mind, for this example, you could have gone straight from cotangent theta to cos theta divided by sine theta, because that is one of the identities. It's just that in my head, when I was breaking it down, it made more sense to go from here to here to there. But yeah, totally acceptable if you want from here to there, as long as you explain the steps, which is the quotient identity. Well, next, I'm noticing that we're dealing with adding and subtracting fractions, but the two terms have different denominators, and I need to identify the LCD. See how you're bringing that rational function unit. So the LCD is cos theta and sine theta. To my first term, I don't have to do anything, but I do have to multiply the top and bottom by cos theta. And so I have equals 1 over cos theta sine theta minus cos squared theta divided by cos theta sine theta. I could put the two together. The numerators, I just have to put once on the top, meanwhile I have the numbers on the bottom. In terms of my 1 minus cos squared theta, so looking back here, so I know that I need my left side to try to look like my tan theta. And I know tan theta is equal to sine theta divided by cos theta. So that means I want to introduce this so that it becomes sine squared theta. And I can do that because of Pythagorean identity. And as a next step, I have sine squared theta divided by cos theta sine theta. These parts will cancel out. And so you have sine theta divided by cos theta. And you can do two things at this point. One thing you can do is you can make the right side equal to sine theta divided by cos theta. That's perfectly fine. But I'll just continue and say this is equal to tan theta. Therefore, left side is equal to right side. All right, question F. So this is the left side, this is the right side. All right, it's kind of hard sometimes to figure out which side to work on, which is the hard part of trig. But right here, you are dealing with brackets squared, which means I can FOIL and expand and simplify. So I'm going to first work on that side. So recall that it's a lot more simple if you have this now by memory, because you've used this and expanded and simplified so many times that when you have a plus b squared, that's the same thing as writing it twice. And by FOIL, you'll have the following, which always simplifies to a squared plus 2ab plus b squared. So rather than writing that 3 steps within here, it's a lot easier if you have that kind of in your head. And so then you have sine squared x plus 2 sine x cos x plus cos squared x. So if you need to visually see this, this is like my a squared, and that's my 2ab, and that's my b squared, and notice that they correlate. So from my previous step to the next, I did FOIL and simplify. So I noticed that there's a 1 here, right? So which means that I probably can use my Pythagorean identity. So I'm going to bring these two together. And I'm just going to collect it towards the front. So you see that I'm going to put these together to make and use the Pythagorean identity. And so I have, by Pythagorean theorem, that is equal to 1 plus 2 sine x cos x. So the things with trig is sometimes one looks complicated, but this only required 3 steps, so it wasn't that bad. So trigs vary based on their difficulties. So therefore, left side equals right side. Keep in mind, all of this worked out, but you might have a situation that it's actually not a true identity. If I had made this right side so that this was like a 2, then the left side and right side wouldn't equal, and therefore it would not be a true identity. So just keep in mind that you may have to deal with proofs that don't work. And that's why we do the proofs. The proofs aren't supposed to work 100% of the time.